we talk about trigonometry, we are talking about the study of triangles in relation to their sides and their angles. Okay. For this class, we're going to consider what we call a right-angled triangle. Okay, we know that there are types of triangles. We have the acute angled triangles, obtuse angled triangles. We have the right-angled triangle. We have equilateral triangle. Have isosceles, scaling triangle. Okay, so all of these are types of triangles. Okay, but in today's class, we're considering this special case, the right angle triangle. What is a right angle triangle? A triangle, okay, it has an angle of 90 degrees. That angle of 90 degrees is called right angle. So when you hear of right angle, it means an angle of 90 degrees. So for any right angle triangle, if we have it to represent a right angle triangle, this symbol here means that it's a right angle. It's an angle of 90 degrees. Let's call this triangle A, B, and C. Okay, let's call this triangle A, B, C. The right angle is at C, and let's assume that we have an angle here. Okay, in fact, I'm going to bring two versions of this triangle, the same A, B, and C, and then we have an angle here. Okay, so you see, the same triangles, but the angles are in different position. Okay, so anytime you see a right angle triangle, the side that is facing the 90 degrees is called the hypotenuse. Okay, the side facing the angle is called the opposite. Once you've named your hypotenuse and your opposite, the remaining side is called adjacent. Okay, so in this other case, this is also going to be our hypotenuse. This side is our hypotenuse. Because the angle is here, here will now become our opposite. And then the other side is called adjacent. So opposite is not down or side. It depends on where your angle is. Wherever your angle is, the side opposite to it is called the opposite. In fact, that's where the name comes from. Opposite to the angle. Okay, that's why it's called opposite. Opposite to the angle. And the other side is called adjacent. Basic trigonometric ratios. The basic trigonometric ratios are the sine, the cosine, and the tangent. And we're going to define them shortly. Tangent. So let's give this case. Here is A, here is B, here is C. Let our angle be here. From what we've done so far, here is our hypotenuse, here is our opposite, and here is our adjacent. So we can now define sine theta. The sine of this angle is opposite over hypotenuse. Opposite over hypotenuse. In this case, sine theta is going to be AC, which is our opposite, line AC all over, hypotenuse, line AB. Line AB. One other thing we need to understand is, given any triangle, the capital letters are used to denote the angles, and small letters are used to denote the sides. So the side facing a capital letter is going to be represented with a small letter of that capital letter. All right. So if here is angle A, the side facing this angle is going to be called side A. If here is angle B, the side facing angle B is going to be called side B, and the side facing angle C is going to be called small letter C. Okay. So here is capital letter A, the side is going to be small letter A. Here is capital letter B for angle. The side facing is going to be small letter B. Okay, if we do that same thing here, we're going to have here A, here is B, and here is going to be C. If we do the same thing here, we're going to have C, here is A, so here is going to be A, here is B, so here is going to be B. Which means if we define this sine theta in terms of letter, opposite is small letter B, and hypotenuse is small letter C. So we can say sine theta is B over C. But we don't define it as B over C. It depends on the triangle. Please, depend on the labeling of the triangle. Okay, so the definition is opposite over hypotenuse. Cos theta is defined as adjacent over hypotenuse. Adjacent is A, and hypotenuse is C. How about tan theta? The definition of tan theta is what? Opposite over adjacent. Okay? And in terms of letter, opposite is B, adjacent is A. So this can be remembered using the acronym SOHCAHTOA, SOHCAH and TOA. So S stands for sine is equal to opposite over hypotenuse. C stands for cos or cosine is adjacent, H hypotenuse, and T stands for tan is equal to opposite, A stands for adjacent. 1 over sine theta is called cosec. Cosec theta. 1 over cos theta is called sec. Okay? Or you call it secant theta or sec theta. And then 1 over tan is called cotangent or cot. So this is cot theta. So just take note of this. We're not going to be looking at this in this class. We're just going to be focusing on this. But I want you also to note that we have something like this in mathematics. To derive special angle for sine 45, we're going to make use of a right angle triangle with 45 degrees. If here is 45 degrees, here will also be 45 degrees because it's a right angle. Here is going to be 90 degrees. So remember the sum of angles in a triangle is what? 180. So if here is 90, 45 plus 45 is 90, giving us 180 total. Okay? So for this triangle, we each of the side is 1 and 1. So here is 1, here is 1. Okay, so you remember Pythagoras theorem that hypotenuse squared is equal to opposite squared plus adjacent squared. Okay, so because we're not considering any angle, we can use anywhere as our opposite and anywhere as our adjacent. So let's calculate. Hypotenuse squared is equal to 1 squared plus 1 squared. Here is opposite and adjacent. Any of them can be opposite, any of them can be adjacent. So we have the hypotenuse squared is equal to 1 plus 1. Hypotenuse squared is equal to 2, which means to get the hypotenuse alone, it's going to be root 2. So here is going to be root 2. Now we can define the trigonometric ratios for 45 now. So let's begin with sine 45. What's the definition of sine? Opposite over hypotenuse. Is that true? So look up, pay attention. We have opposite over hypotenuse. From our diagram, where if we let's consider this angle, where is our opposite here? What's the opposite? 1. Is that 1? And what is our hypotenuse? Root 2. So sine 45 is the same thing as 1 over root 2. We did solve recently. And what did I say about solve? Anytime you have a solve in denominator, what do? You rationalize. Exactly. So let's rationalize that. So we're going to have 1 over root 2 times root 2 all over root 2. 1 times root 2 gives us root 2. Root 2 times root 2 gives us root 4. And root 4 gives us 2. So root 2 over 2. What this means is that sine 45 is root 2 over 2. So take note of this. What is cosine? Adjacent over hypotenuse. From the diagram, we are still considering this angle. So our adjacent is 1. Okay, so 1 over root 2, which we have already done something like that. So 1 over root 2 is also the same thing as root 2 over 2. So cos 45 is the same thing as sine 45. Tan 45. Opposite over adjacent. Okay, what's our opposite from there? 1. Is that? And what's our adjacent? 1. So it means that tan 45 is equal to 1. For us to get the trigonometric ratios for 30 and 60, we use an equilateral triangle with sides 2 units. Okay? Remember that for an equilateral triangle, each of the angle is 60 degrees. 60 and 60, because sum of angles in a triangle is going to be 180. And then let's bisect this angle here to get 30. This line will also bisect here and here. So if from here to here is 2, from here to here is going to be 1, and here is going to be 1. So if we take out one of the triangles that we just formed by cutting it out, we're going to have something like this. Here is now 30. We divided it into 2. Here is 2. Since we divided into 2, one part is going to be 1. We don't know what here is. Okay. So let's calculate this side using Pythagoras theorem again. From this configuration, you can see that here is our hypotenuse. Okay. Any of these can be, remember this angle, let's note that this angle is 60 degrees. Here is 30 degrees. So from Pythagoras theorem again, Pythagoras theorem, hypotenuse squared, which is here, is equal to, in fact, let me just put the values. Hypotenuse is 2 squared is equal to one of the sides, 1 squared plus. This side is what we're looking for. Let's just call it y. Okay, so 2 squared is 4, 1 squared is 1 plus y, and then 4 minus 1 is equal to y. So this is going to be y squared. So y squared is going to be 3, y is going to be root 3. So this side is root 3. So root 3 here. If we're considering 30, here is opposite, here is going to be adjacent. So that means that sine 30 is going to be opposite, which is 1, over hypotenuse, which is 2. So sine 30 is 2, which is 1 over 2, or 0.5. What about cos 30? Cos 30 is adjacent. If we're considering 30, here is adjacent. That's root 3 all over. Hypotenuse is 2. So cos 30 is root 3 over 2. What about tan 30? Tan 30 is opposite, which is here, over adjacent. That's here. 1 over root 3. When we rationalize, we're going to have times root 3 over root 3. This is going to give us root 3 over 3. So tan 30 is root 3 over 3. Now, if we're considering 60, here becomes our opposite. And here is our adjacent. So let's take note of that. So for sine 60 now, we have opposite root 3 over 2. What about cos 60? Cosine is adjacent over hypotenuse, 1 over 2, or 0.5. 0.5. What about tan 60? Tan 60 is opposite over adjacent. This is 60. So opposite over adjacent. Root 3 over 1, which is root 3. So what I'm going to do, let me get all of these things that we just derived so that you see them side by side. You can see that sine 45 and cos 45 is the same thing. Okay? You can also see that sine 30 is the same thing as cos 60. And then sine 60 is the same thing as cos 30. So there is a relationship we have that the sine of an angle is the same thing as the cos of 90 minus that same angle. Let me show you how this works. Okay, remember that these two things have to add up to 90 because the sum of angles in the triangle is equal to 90 degrees. Do you understand? Okay, so it means that if here is 60, here needs to be 30. If here is 70, there needs to be 20. If here is 55, what do we add to 55 to get 90? We add 35. So these two angles must be complementary. Okay, so the sine of an angle is something as cosine of 90 minus that angle. So it means that sine 60, what do we add to 60 to get 90? 30. Sine 60 must be equal to cos 30. And that is what we're seeing here. So you can see sine 60 is this, cos 30 is the same thing. Okay? So it also means that sine 30, what do we add to 30 to get 90? 60. Sine 30 must be equal to cos 60, which is what we're also saying there. Okay? So why is sine 45 and cos 45 the same? Let's say sine 45. What do we add to 45 to get 90? What do you add to 45 to get 90? 45 again. That is why sine 45 is the same thing as cos 45.